We're going to talk about sequences and write them as functions. So we're going to be able to define them and then write them as a linear function and an exponential function. So what the heck is a sequence? Well, a sequence is a set of numbers in a particular order or pattern. Each number in the sequence is called a term. A sequence may be a finite sequence containing a limited number of terms. A sequence that continues without an end is an infinite sequence. So those are just some vocab words there for you. With a sequence, it is a function in which the domain is the number of the term, or in this case, the position of the term. So essentially we have a table with your position of each term. So this is the first term, second term, third term, and so on. And then the range is going to be the terms in the sequence. So when we make tables, your domain is always going to be the position, and the term is always going to be the range. So here's a finite sequence where it ends, infinite where it goes on, dot, dot, dot. A domain will be natural numbers, so that's your counting numbers. And your range then will be whatever is the sequence, the terms in the sequence. So an arithmetic sequence, each term is determined by adding a constant value, aka the common difference, to the previous term. So what I would like to do on these examples is determine whether or not these are arithmetic sequences. Are we adding a constant each time? Do they have a common difference? Well, here we go from 5 to -6, so we're technically adding a -11, adding a -11, adding a -11. So yes, this is an arithmetic sequence. What about the second one? Are these arithmetic sequences? -4 to 12 is 16. 12 to 28 is 16. 28 to 42 is 14. So is this a sequence? No, it's not. Here's another example. Find the next 4 terms in the sequence. So the common difference is going to be a -4. So we could keep going with that. So we could have 6, 2, I don't know why I wrote it like that. I'm sorry. Let me fix that. That looks silly. 6, 2, -2, and -6. So -4. Okay, and it works out there. Now, writing this as a linear function. So like what we saw in a couple slides ago, we want to make a table where your domain is going to be the number of values. So we have 1, 2, 3, and so on. So here, our table, or our first term rather, would be 18. Second term is 14. Third term is 10. Fourth is 6. So in order to write a linear function, we need to have in the form of y equals mx plus b. Now keep in mind, m is how it changes. That's our slope. So how is this changing the sequence? Right, it's -4. Now, do you remember what b was in y equals mx plus b? It's your starting spot. So where does this start? Well, we need to figure out what is our sequence when we have 0. When we plug in 0, where would that be? Right, it would be 22 because we're adding a -4 each time. So b would end up being 22. So if we put this all together, we have y equals a -4x plus 22. And that would be the equation. What about this one here? Geometric sequences. Have you heard of those before? A geometric sequence, each term is determined by multiplying by a constant. We call that a common ratio. So are these sequences geometric? What are we multiplying by here? -3, -3, and -3. So this one is a yes. What about this one? We're multiplying by 2, We are not multiplying by 2 here. We're actually multiplying by 1.5, and then we multiply by 1.3 repeating. So this one is no, it's not. Now, writing equations with geometric sequences is kind of fun. Here we have 32, 8, and 2. Oh, and I just realized this. This should be 32 right here, not 22. Sorry about that. So these three terms, 32, 8, and 2, what are we multiplying by each time? Right, we're multiplying by 1/4. Dividing by 4 is the same as multiplying by 1/4. So I'll write that here, 1/4, 1/4. And let's see, the next term would be 1/2, then 1/8, and then 1/32. That would be the next three terms. So writing an equation. Now we need to look at the graph for this. And before we look at the graph, let's make a table. Let's do that instead. So our first term, make a table here. Sorry, I don't know why this is not writing right. So the first term is 32. The second one is 8. The third one is 2. The fourth one is 1/2, and so on. So to make an equation out of this, it might be helpful to see what the graph looks like, and then we might be able to discover what kind of equation we're looking for. This looks pretty familiar, doesn't it? Right, it's exponential. So exponential, remember, takes on the form of y equals a times b to the x, where a is your starting spot, and then b is what we're multiplying by. So we need to figure out what our starting spot is. So what is it when it's 0? So if we're multiplying by 1/4 to get to that, right, it'd be 128. 32 times 4 is 128 because we're multiplying by 1/4 as we go down our table. So that's going to be our A, is going to be that value when x is 0. Now, B, what are we multiplying by, is 1/4. So our equation then is going to be y equals 128 times 1/4 x. So just keep that in mind. This is your starting spot, and this is what we're multiplying by, okay, when we write those equations. All right. So in this Google form below, what is this, an arithmetic or geometric sequence, and why? So look at these numbers here. Tell me which one it is, and then explain why. So you have 2 answers you have to give me. Alrighty. That's all I have for you guys. Have a great day. We'll see you later.